Have you ever wondered how top tier engineers handle millions of data points without breaking a sweat? Most people get stuck in the slow lane of ON square or ON cube. But today we are breaking through. Hello everyone, I am Supratim and welcome back to Techmine Guru. Today we are moving from brute force to pure efficiency as we dive into advanced array optimization. So in our journey till today, we have covered the foundation and array patterns, where we learned about introduction to problem solving, the time complexity and BIGO covered in lecture 2 and lecture 3, the array, then prefix sum pattern, then carry forward and subarray techniques, then sliding window and contribution techniques, basic sorting, basic 2D matrices and string manipulation, and finally the bit manipulation basics and some interview problems. So our module 1 is complete here. So congratulations guys, we have moved on to module 2, where we will learn about advanced arrays, recursion and some number theory. So today we are going to start with our advanced array optimization. Now today in lecture 14, we are focusing on the art of one pass solution. So here is our roadmap today. So the stock and the market problem is one of our problem, where we will see how to maximize profit with Subarray Sum, the range query, where we will handle millions of updates efficiently, and finally how to solve the rainwater trapping interview problem. All we will learn from brute force O of n square to the optimization of O of n. So let's start with the stock price optimization problem. Imagine you have an array representing daily price changes, positive or negative. So positive for profit and negative for loss. Your goal is to find maximum subarray, right? So if you use brute force, you will start a loop from for I is equal to 0 to n minus 1, which will tell your start index, and then inside that you will run a loop from for j is equal to I to n minus 1, which will tell your end index, and finally when you will iterate from I to j in your k loop, you will sum up and you will try to maximize the answer, right? But this will be O of n cube, which is very slow. Even if you try to do prefix sum optimization or carry forward, that will again give you O of n square only, right? Here the space complexity will be O of n, but in carry forward, since we don't take any extra space, the space complexity will be O of n only. But can we solve this in a single pass O of n? Definitely. The solution is using the Kadane's algorithm. So the intuition behind the solution is, if a subarray sum becomes negative, it cannot contribute positively to the future. So if sum is lesser than 0, you have to reset the sum to 0. But there are some observations into it. What if all the elements of the array is greater than 0? That time answer will be summation of all the elements of the array. For example, 4, 5, 2, 1, 6. What is the maximum subarray sum? The maximum subarray sum will be the cumulative sum of all the elements of the array, which will be 18. What if all the elements are lesser than 0? That time max of the array elements will give you the maximum subarray sum. So for example, if you take the example of minus 4, minus 1, minus 3, minus 6, minus 9 and minus 2, the answer will be minus 2 only, because in this array the max element will be minus 2 only. Suppose if array has pattern like negative, negative, positive, 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 and then negative, negative, then just we need to focus on the positive areas, because that positive area will only give us the maximum subarray sum. Similarly, if you have a starting with some negative numbers and then positive numbers, or starting with some positive numbers then negative numbers, we just have to focus on the positive numbers, which will give us the maximum subarray sum in our case. Similarly, if you have alternating signs, right, positive, positive, negative, negative, and again positive, positive, then you just have to focus that which positive side is giving you the maximum subarray sum, right? So let's understand how to write Kadane's code. So the code is very simple. You have to take two variables, answer, which you can initialize as first element, and then you can keep a sum equal to 0, and then you will run a loop from for I is equal to 0 to n minus 1, and you have to keep summing up all the elements. So if your sum is greater than the answer, you will set answer as the sum, but if your sum is lesser than 0, you will reset the sum to 0. So let's visualize that with a dry run. So suppose you have given the array A minus 7, 3, minus 5, 8, and minus 2. So initially answer will have minus 7, right? And the sum is 0. Now, since we are starting from for I is equal to 0 to n minus 1, the sum will be a of 0, which will be -7 now, right? -7 is not greater than -7, so this if will not work. But -7 is lesser than 0, we will reset the sum to 0. So that's why our current sum will be 0 now, right? So our current sum will be 0. Now we will move to the second element 3. In our sum, 0 is there. So 0 plus 3 will give the sum as 3 now, right? Since 3 is greater than -7, because in our answer we still have -7, so the answer will be set to sum. So now our answer will be set to sum, which is 3, right? And since sum is greater than 0, this if will not work. Now we will again move to the next element, which is -5. So here sum will be equal to 3 plus of -5, which will be -2, right? Since -2 is not greater than 3, again this if block will not work, but sum is lesser than 0, so we will set the sum to 0 again. So the sum will set to 0 now. Now we will move to the fourth element, which is 8. Since sum is 0, 0 plus 8 will give as sum as 8 now. Since 8 is greater than 3, we will update the answer as the sum. So now answer will be 8, right? Because this if condition will work, right? Since the sum is coming as 8 and in the answer we have 3 earlier. And since sum is greater than 0, this if block will not work. Finally, when we will move to -2, our sum will be 6, right? And now 6 is not greater than 8. So this condition will also not work. And since sum is not lesser than 0, this if block will also not work. So what will be our final answer? So answer will be 8. So if you closely look in this array, the maximum subarray sum will be given by 8 only. So if in this question, if it is asked that how to find the subarray which is giving the maximum subarray sum. So for that, you can keep 2 pointers at L is equal to 0 and R is equal to 0, right? And along with that, you have to keep one more variable as start index, right? Why this is needed? The start index will be needed because every time you reset the sum, your start index will change. So here, just small change, that L should be equal to start index and the right pointer will be pointing to the I. And here, whenever you are resetting sum, you have to mark the start index as I plus 1, right? So like this, it will give you the L and R, which will tell you that from L to R range, this is your maximum subarray, which is giving the maximum sum. So this will be your subarray. So let's move on to the second question, range updates. Suppose you have been given an array of size n filled with zeros, and you need to add a value x to indices present from I till j across multiple queries. So suppose this is the array which is given initially, which is filled with all zeros. Now you have been given one query where the first element will tell you the start index and the last element will tell you the end index. And third element will tell you that how much you have to add in that index. So since 3 you need to add from 1 to 4, so 3 has been added in 1, 2, 3, 4. Similarly, if the second query is given as from 3 to 6, you have to add 1. From 3 position to 6th position, you have to add 1. So this 3 will become 4. This 3 will become 4. 1 will add it here, it will become 1. 1 will add it here, it will become 1. So the final output will be this. So in this, if you loop for every query, you will get O of Q cross N. And if Q and N are of very higher range, then we will definitely get a TLE, right? So how do we optimize this? To optimize this, we use difference array. So instead of filling the whole range, we just mark the boundaries in the starting. So how will you mark? So you will mark the start position and you will add that value into that element, and you will mark the end position where you will subtract the value from that end element, right? So this will convert into O of 1 per query. So let's visualize it for the previous example. Initially, all the elements were 0, right? And for the first query, 1 to 4, you have to add 3. So if you put this formula, so in the first position, you have marked it as 3, right? Similarly, this is the 4th position and this will be the 5th position. So j plus 1, you have to mark it with minus of 3. So you have put minus 3 here. Similarly, for the second query, in the third position, you have added 1, and in the sixth position, you have added minus 1. So the first step is complete here. You have marked the boundary, and your array looks like 0, 3, 0, 1, 0, minus 3, 0, minus 1, right? Now, in the second step, you just have to compute the prefix sum. So how do you calculate the prefix sum? 0 plus 3 will give you 3. 3 plus 0 will again give you 3. 3 plus 1 will give you 4. 4 plus 0 will give you 4. 4 minus 3 will give you 1. 1 plus 0 will give you 1. And 1 plus minus 1 will give you 0. So the final array will be 0, 3, 3, 4, 4, 1, 1, and 0. So this is the code for difference array, where suppose you have q queries and you are running a loop for k is equal to 0 to q minus 1. So since the query array will be like 2 dimension and the length of the array is of k length, here we are getting the start index, which we will get by q of k comma 0. K of 1 will give end, and the value will be given by q of k comma 2. So just you are applying the formula where you have mentioned a of start plus equal to val, so that every time you mark the boundary and you keep adding all the elements for the queries related to the start position. And similarly, then you have to check whether end plus 1 is lesser than n or not, and you just have to subtract the end element, right? And in the step 2, you just have to iterate through a loop from I is equal to 1 to n minus 1. I has been taken from 1 because in this we will do a of I plus equal to a of I minus 1. Since I has been started from 1, so that if it calculates a of 0 also, otherwise index out of range will come, right? So this is how you will accumulate all the array. So what is the time complexity? The time complexity will become q plus n. Why? Because in this we are iterating a loop from k is equal to 0 to q minus 1, and here we are iterating a loop from I is equal to 1 to n minus 1, which is the length of the array, right? So the total time complexity will be O of q plus n, and the space complexity will be O of 1, since we are not taking any extra space, right? Finally, let's tackle the hard interview classic problem, which is the rainwater trapping problem. So suppose you have been given an array which is like height of a building, and you have to find out that how much water will be trapped in between the buildings. So if you see here, water will accumulate in this position, the water will accumulate whose length will be this one, and here there will be no water, right? Because there is nothing in right of this. So the formula which we can apply here will be water accumulated at any ith position will be min of max left comma max right. So if you want to see the what is the amount of water accumulated here, it will be max left. So which is the max left here? 2, right? And what is the max right here? 4. So what is the min of both the area? It will be 2, right? And we have to subtract the height of that. So the height is 1. So 2 minus 1. So the water at 1 will be 1 unit only. Similarly, if you see for this part, so for this, how much it will come? So the max right will be 6, right? And max left will be 4, right? What is the min of max left and max right? It will be 4. The building height is 3. So here the water accumulated will be 1, right? Also you can visualize it, right? From 4 to 3. Similarly for this you will get 2, right? This length. And similarly for this you will get 3. So what will be the amount of water getting trapped? 3 plus 2 plus 1 plus 1 from here. It will be somewhere around 7, right? So let's think about the brute force first. So for brute force, you have to search left and right of every single building, right? So whenever you come across any building, you have to search for the left maximum and the right maximum. But it will be O of n square, right? So brute force would have us search left and right for every single building, which will cost us O of n square. So instead of that, let's see how we can use a pre-computation strategy. So as we have learned about prefix sum, similarly, if we tell about prefix max, what it will give? It will give that max element till that index. So this prefix max array will store maximum height seen till that index. Similarly, there is something called suffix max, which will be from right to left, right? Which will tell us, which will store the maximum height from end to current index, right? And finally, we using that water formula, we can calculate the water accumulated at that part if we have already pre-calculated both of them. So let's understand that with a dry run. So suppose we have been given the array, which is like height of the array, 2, 1, 4, 3, 1, 1, 6, and 2. Since you already know how to calculate a prefix sum, similarly, you will calculate prefix max. So the first element of array will be as it is coming to the prefix max array. So maximum of these two elements will give the second element prefix max, which will be 2. Similarly, for 4 and 2, the prefix max will be 4. Similarly, for 4 and 3, the prefix max will be 4 again. Similarly, for 4 and 1, the prefix max will be 4 again. Similarly, for this 4 and 1, the prefix max will be 4 again. Now, for this 6 and 4, the prefix max will change to 6. And similarly, for this 6 and 2, the prefix max will give 6 only. But for suffix max, we have to calculate from the end. And for that, we will just copy the value of the end element and we will start the loop from the end. So this 2 and 6 will give maximum as 6. Similarly, this 6 and 1 will give the maximum as 6. This 6 and 1 will again give the maximum as 6. This 6 and 3 will again give the maximum as 6. This 6 and 4 will again give the maximum as 6. This 6 and 1 will again give the maximum as 6. And this 6 and 2 will again give the maximum as 6. So at any point, suppose you want to calculate what is the amount of water stored at here. So it will be prefix max till the third index and suffix max till the fourth index. And minimum of prefix max of third index, comma, suffix max of fifth index minus a of 4, which is the height of this index building, will be min of 4, comma, 6, which will be 4, right? And height of this building is -1. So we are getting 3 units of water here. So let's finalize everything by seeing the code. So this is how we are calculating the prefix max array. And this is how we are calculating the suffix max array. For the prefix max, we are starting from for I is equal to 1 to n-1. And here prefix max of 0 will be a of 0, right? We have already learned this in the prefix sum. Similarly, here also suffix max of n-1 will be equal to the last element, since we are starting from the right side to the left side. So now the loop will start from I is equal to n-2 and it will reach till 0. And suffix max of I will always give suffix max of I plus 1, comma, a of I. Now to calculate water, we will just run a loop from for I is equal to 1 to n-2. Why we are leaving I is equal to 0 and I is equal to n-1? Because they are like corners. They can't trap any water. That's why we are just removing that, right? Now we will apply this formula, minimum of PFM of I-1, comma, SFM of I plus 1 minus A of I, the height of the building. And if water is greater than 0, then only we will add the water in the answer, right? Because maybe the height of the building can come more than the mean element of these two, prefix max and suffix max, right? So that's why we have added one extra condition. If water is greater than 0, then only we will add, so that we don't adding the negative water. So what is the time complexity of this? So this will give O of n, right? This will also give O of n, right? And this will also give O of n. So the total time complexity will be O of n plus n, which is O of 3n, which is again approximately O of n. And also the space complexity here will be O of n only. Why? Because we are creating two extra arrays, one for the prefix max and second for the suffix max. Now let's summarize what we have learned today. So today we learned about Kadanes and how Kadane help us to carry only the profit, right? Then we learned about difference array, which helped us to mark boundaries instead of filling ranges, right? And at last, we learned about pre-computation strategies using prefix max and suffix max array, which replaces repeated searches, right? because they are giving simple lookups when you iterate within this for loop, right? So if you found this helpful, hit that subscribe button. In our next lecture, we are going even deeper into advanced 2D matrices. So with this, I am Supratim signing off for today. Until then, keep coding, keep optimizing, and keep learning. And I'll see you in the next one.